The last presentation is entitled Injection to Seal Cracks in Concrete. It will be made by Etsuji Kikuta. Etsuji Kikuta is staff of the Hokkaido Regional Development Bureau, MLIT, Japan. Before, he worked in the Civil Engineering Research Institute for Cold Regions as deputy leader of the materials team. I ask now Etsuji to please share your presentation, and the floor is yours. Whenever you're ready, you may start. Thank you.
Thank you. I am Etsuji Kikuta. I would like to serve as the final presenter of today. My contribution to Bulletin 102 is injection to seal cracks in concrete. But in today's presentation, I would like to call it crack injection for simplicity. Crack injection is one of the most representative repair methods for concrete structures. It is a method that prevents deterioration factors such as water and salt from entering the cracks by filling the cracks with injection materials. It is applicable to both remedial and preventive maintenance. It is effective for cases where preventing the moisture intrusion is expected to slow or suppress progress of deterioration, such as cross damage and ASR. However, it is not effective against cracks caused by river corrosion, such as salt damage and carbonation. There are various crack injection materials which have performance corresponding to the condition of cracks to be injected. Also, there are several types of injection methods and injection tools. Therefore, it's important to accurately judge the condition of cracks and the execution environment, and to appropriately select materials and methods. Without appropriate selection, early redeterioration may occur. In advance, I would like to introduce the materials that were mainly cited in the contribution to the bulletin. This is a guideline for concrete structural repairs published by Public Works Research Institute in 2016. Although it is only published in Japanese, it is expected to be utilized by all engineers involved in concrete repair, and it is available for free download, and it is already being utilized by many engineers. This is contents overview. Today, I will explain basics, design, and case study from among these. A case study also includes examples of design, execution, and so on. This is content of basics. There are several types of both injection methods and injection materials, and appropriate selection must be made according to the state of cracks and the execution environment. Therefore, the characteristics of each materials and methods are important information. About crack injection materials. Crack injection materials are broadly classified into resin type and cement type. In the resin type, there are products with various viscosities, and the applicable crack width depends on the viscosity. And since the viscosity of injection materials tends to be affected by temperature. So, ambient temperatures and concrete temperatures are important management items. Curing time is also affected by temperature. The cement type is the same materials as the structure to be repaired. And the crack inside is excellent in terms of density and solidity. But since the tensile strength is low and there is no probability, it cannot be applied to cracks with opening and closing behavior. In addition, since the viscosity is low, if the crack width is large, it tends to fall down and cause poor fitting. There are two types of crack injection methods. One is the manual or the mechanical injection method, in which injecting at high pressure in a short time. The other is the automatic low pressure injection method, in which injecting over time with low pressure and low speed. The manual or the mechanical injection method is a simple injection method that does not require special tools. On the other hand, skilled workers are required for execution. The automatic low-pressure injection method enables reliable and stable injection. So, execution management is easy. A special tool is required, but after filling the tool with injection materials, no manpower is required. Because of the low pressure, there is little leakage from the shield and no skilled worker is required. But the working days tends to be longer, including the preparatory work. About design, here I will cover selection of injection materials. At first, about resin type materials, there are a rigid type and a soft type in the resin type materials, and each type has materials with various viscosities. A material with an appropriate viscosity must be selected according to the crack width, environmental temperature, and other execution environments. Generally, the rigid type is less expensive, but the rigid type does not have flowability. So it is not applicable when the cracks has opening and closing behavior. The soft type is applicable to such cracks. Next, about cement type materials. Cement type include products with and without emulsion polymers, but product containing polymers which has higher adhesion are common. For application in cold climates, products containing polymers are more resistant to frost damage. It can be applied even in wet conditions, but since materials will not cure in cracks with a large amount of water supply, it is necessary to apply the materials that can be cured quickly. And cement type generally have no flowability, so they are not suitable for cracks with opening and closing behavior. So here goes into the case study description. The target structure was a bridge abutment on a national highway that had been built on the plains in the cold, snowy region 24 years ago. At the time of construction, cracks had occurred due to temperature stress, but the surface crack width was less than 0.02 millimeters, so this structure was not repaired immediately and it was kept under observation. Then, efflorescence deposition from the cracks was confirmed in the inspection 20 years after construction, and the surface crack width had expanded slightly to about 0.2 to 0.4 millimeters. Therefore, a detailed investigation was carried out and repair interventions were considered. Detailed investigation had conducted for 2 years in order to confirm the progress of cracks. Photos shows investigation of the state of blockage on the crack surface. The photo below shows a general investigation method by core sampling. The photo above shows a method called cross-cutting, in which a cut is made at the right angle to the crack using an electric tool. By the way, using this cross-cutting method makes it possible to create injection ports and inject materials even into cracks that have surface blockage. Detailed investigation revealed that the cracks had penetrated and that reinforcing bars had not yet corroded, and so on. Also, it was presumed that the cracks had progressed due to the influence of moisture supplied to the inside of the crack. Based on these factors, it was judged that interventions were necessary to prevent corrosion of the reinforcing bars. About design of intervention method. Repair policy was set to suppressing the invasion of deterioration factors and protecting reinforcing bars. There were also repair methods other than crack injection that was suitable for these repair policies. However, since the target crack was penetrating and water entered from the backside, so it was necessary to completely fill not only the crack surface, but also the inside of the crack all the way to the backside. Therefore, the crack injection method was the most suitable. Also, both the crack width and environmental temperature were within the applicable range of the crack injection, and the surface blockage could be handled by cross-cutting method. Based on these, it was decided to apply the crack injection method. About selection of injection materials and injection method. Due to the penetrating cracks, cement type could flow out the back and result in incomplete filling. So, resin type injection materials was suitable. The crack width was often around 0.2 millimeters. It's relatively narrow, so low viscosity injection materials was suitable. There was no crack opening hand and crack closing behavior, so followability is not required. Therefore, inexpensive rigid types was suitable. As an injection materials that satisfied these conditions, rigid type, low viscosity, epoxy resin injection materials was selected. As for the injection method, since the cracks were linear, it was judged that injection was possible even at low pressure. So, the automatic low pressure injection method was selected. The photo shows the actual injection situation. Here, air pressure injection type devices were used. Since water leakage occurred from cracks during rainfall, it was carried out in fine weather. Injection ports were created at intervals of about 200 to 300 millimeters, and investigation ports by cross-cutting and cross-sampling were also reused as injection ports. In order to ensure the quality, the following items were managed. Management of temperature and curing time is especially important. About the inspection after execution. Since the cross-cutting method had little execution record at that time, small diameter cores were taken after injection curing, and the filling state of the injection materials was confirmed. As shown is in the photograph, injection materials had completely filled the cracks as far as the eye can see. Then, 1 year after execution of repair, the inspection of repair site was carried out because if early redeterioration occurs, there are many cases that occur within 1 year. It was carried out during rainfall in order to confirm whether there was water leakage. Even during rainfall, there was no leakage of water from the cracked portion and no occurrence of precipitate. From this result, it was confirmed that the suppression of water intrusion were sustained. That's all for my presentation. Thank you for listening to my poor English. Thank you.
Thank you, Etsuji. Etsuji was afraid his English was not clear, but I must say it was quite clear, your presentation. Thank you very much. I don't know if there are any questions. There are not in the Q&A window, but as previously, you may raise your hand and I will turn on your micro and you can raise the questions directly to Etsuji. Okay, is Tiago Vieira? Well, he's just saying that it was an interesting presentation and is thanking Etsuji. Gassin Ahem has a question. The question is, how can we decide which method to use? Etsuji, can you try answering this question?
Yes, I can see how to decide which method to use,
Yes.
low pressure or high pressure. In this case, because flux is linear, so at low pressure since the cracks were linear, it was judged that injection was possible even at low pressure. Low pressure method is execution management is easy, so that in this case it was decided to use low pressure type method.
Thank you, Etsuji.